Hi, we're going to discuss the examples in notes chapter 7. So we're going to look at example 10. The question states that a biconvex lens is made up of a glass with refractive index of 1.52 having the radii of curvature of 20 centimeter respectively. Calculate the focal length of the lens in water and carbon disulfide given the refractive index of water such as 1.33 and refractive index of carbon disulfide 1.63. So in the question, what we have here is a biconvex lens with a refractive index of 1.52. This is the refractive index of the glass, or we call it as the material. This is the refractive index of the material, which is the material made for to make our lens here. And also given in the question, the radii of the curvature of the the radii of curvature is 20 centimeter respectively. 20 centimeter respectively, which means that your biconvex lens, this is the shape of biconvex. Our biconvex lens both has the same radius, which means that the first surface has a radius of 20 centimeter and the second surface also has a radius of 20 centimeter. Okay. Alright, and we know biconvex, they are made of the same spherical lens. They are made from same spherical lens, thus they obviously have the same radius. R should be the same. Alright, so calculate the focal length when we have two different medium where our lens has been immersed, is in the water and also in the carbon disulfide. So we're going to use the equation of lens maker equation, which is 1 over F is equals to N material divided by N medium minus 1 multiply with 1 over R1 minus 1 over R2. Okay, N material is the material that your lens has been made of, and medium is where your lens has been placed. So in our case, we have two situations here. The first one is in the water and the second one is in the carbon disulfide. Okay, so we are going to look for this F here. What is the value of our F? So when we want to substitute the value of our R here, given that R is 20 centimeter respectively, the R here has to, you have to focus on the sign convention of the R before you substitute the value of the R. Okay, how do you deduce the sign convention for your R is, you have to make sure that your object is going to be placed in either side of the lens, either one. So let's say if you choose your object to be placed in the right hand side, in the left hand side in front of your lens here. So this is your object. So you know that the light ray is going to travel from the same side. I mean only from one side. The light is going to travel from here, passes the first refracting surface, first radius, and then it's going to pass through the second radius here. So what happened here is both your R1 and your R2 has to have the light ray that comes from the same side. Okay, they must have the light ray that coming from the same side here. So as the light ray comes from the left here, it hit the first surface here. The first surface here is a convex surface. Convex surface has a positive radius of curvature according to the sign convention. So this one here has a positive 20 centimeter. And our second surface, as the light comes and fall on the second surface, it forms a concave surface. And it forms a concave surface. This indicates that a concave surface has a negative sign for the radius of curvature according to the sign convention. Thus, we have a negative radius here. So when you want to substitute here, 1 over F, for the first case here, for the water, inside the water, you have 1.52 divided by 1.33 minus 1, multiply with 1 over positive 20 centimeter minus with negative 20 centimeter. Then you press your calculator, you will end up with your focal length as 70 centimeter. And then for your part B, everything remains the same except for your medium where your lens has been placed changes. So what happened here? N material over N medium minus 1 multiply with 1 over R1 minus 1 over R2 is still the same. You're going to look from the same side. So your material now is still 1.52. Your medium changes to 1.63 minus 1. So you'll get 1 over positive 20 minus 1 over negative 20 centimeter. So you'll end up with your focal length as negative 148.2 centimeter. Okay, so you have to bear in your mind that for you to substitute the value of your R in the lens maker equation, you have to make sure you consider the sign convention. How do you look for the sign convention of your R is you make sure the light ray comes from the same side and hit both the surface. And then you deduce the shape of your surface is either convex or concave. If it's a convex, it's a positive radius. If it's a concave, it's a negative radius.